Okay, so yesterday we talked about like the base units that we measure things in. Every quantity will have a unit that we measure it with. So quantities would be things like length, or mass, or volume, temperature. You know, those are quantities that we measure, and we're going to measure those with certain units, and most of these units have a standard that they go by. Now, volume is just the amount of space that something takes up. It's not necessarily connected to mass directly. We'll talk about how we can connect them in a moment, but for right now, volume is just how much space something takes up. So that's what we mean by volume, and the derived unit for that is actually a cubic meter, which is pretty large. So we usually don't use cubic meters in chemistry because we're not dealing with this large a quantity of substance. We usually use tiny amounts. In fact, over the years from when I went to college, well, even high school and college, to the way we do labs now, we do labs where we use tiny amounts. We don't need to use huge quantities of substances. You just have more substances that you have to figure out how to dispose of. And I try to pick my labs so that the quantities of substances that we produce, it's okay to just put down the drain. If we did them in larger quantities, then I have to start dealing with how do I get rid of these larger quantities, because then it's illegal for me to just dump them down the drain. But if I do smaller quantities, it's okay. So a cubic centimeter is going to be the more appropriate unit for in here. Do any of you have parents that are work in the medical profession? Anybody in here? If you talk to a particular like a nurse, you know, they'll say maybe that they're supposed to be given so many cc's of something. Well, cc's is just short for cubic centimeter, is what cc stands for. It turns out that it's the same as a milliliter. So one of the things that you may want to write down in your notes, or do we? Maybe we covered it a little bit later, but is that 1 cubic centimeter is equal to 1 milliliter. Okay, 1 cubic centimeter equals 1 milliliter. Be a good thing to remember that all year. So a liter is 1,000 cubic centimeters. And we know that a liter is also 1,000 milliliters, so you can see why it's the 1-to-1 ratio for those two. So 1 milliliter equals 1 cubic centimeter. So I think we might have some assignments or questions where they will have something in centimeters, but maybe it's more appropriate to work it in milliliters, and you can just switch over because they're a 1-to-1 ratio on those. Okay, now, how are volume and mass related to each other? Well, it depends on what substance I'm talking about, because every substance has its own density, and density is mass divided by volume. Mass over volume is density. Okay, so we have this equation here: density equals mass over volume, or we can use it with just letters: D equals M over V. D equals M over V. So that's one formula you're going to have to memorize for the test. I'll just tell you that right up front. You'll need to memorize that. It's not that hard to do that one. The units for density, all you have to do is take what are the SI units for mass, what are the SI units for volume, and then you come up with the density. It's just you just plug in their units. The unit for mass is going to be kilogram, we said, right? And the unit for volume is cubic meter. So the SI unit for density is going to be kilograms per cubic meter. Now that's not the way we normally have it. In fact, when you get your periodic table, hopefully soon, they give the densities down here in the corner, and it's given in its it says that it's in grams per cubic centimeter. So instead of kilogram, we're doing just a gram, so we're dividing by 1,000. And instead of a cubic meter, we are using a cubic centimeter. Now, the part that's maybe a little hard to understand when you're converting units from one to another is to see how that 1 cubic, let's take our physics stuff away here. If I have 1 cubic meter and I want to convert that into centimeters, I have to convert, because remember that cubic meters is what? Meter times a meter times a meter, right? Is a cubic meter, or meters cubed. So when I convert this, I have to do this 3 times. Because there's 3 different meters here. So for one of the meters, I know that there is, for every 1 meter, I have 100 centimeters. That will take care of one of them. And then for the next meter, I have 100 centimeters. That'll take care of the next one. And then I'll have 100 centimeters for the last one. So I have to use the conversion factor once for every unit I'm trying to get rid of. And this one had m times m times m. So how many cubic centimeters in a cubic meter? Well, it's 100 times 100 times 100, which is what? What'd you say, Lennon?
300,000 centimeters.
100 times 100 is what? It's one with 4 zeros after it. So what do you call that?
10,000.
10,000. And what's 10,000 times 100? 10 times 100 is 1,000. And then you had your other 1,000. So it's like 1,000, but you have another set of 3 zeros after it, which makes it
100,000.
what the next thing you were going to say? It's 1 with 6 zeros after it. Million, right? So there's 1,000,000 cubic centimeters in 1 cubic meter. That was a hard one. Okay? It's all the zeros. Everybody probably has their own way of working these problems out in their head. What I always do is I forget about the zeros and multiply them and then count how many zeros. Well, this is 1 times 1 times 1 if I leave the zeros alone, so that's 1. And then how many zeros after it is there? 1, 2, 3, 4, 5, 6. 6 zeros. 1 with 6 zeros, million. So any questions kind of on that? We'll do more of that, but that's kind of get you started on that idea. Okay, so a gram per cubic meter is also equal to a gram per milliliter.
Yeah, that's what I meant to say.
Okay, so here is the density of some different substances. They've measured out the mass, like you had an object and or a container of something, and they measured out the mass, and then they measure the volume, mass divided by volume, and you get these numbers. And you can see that ice, remember we've talked about that in physical science, ice is a little less dense than water. The density of water is 1. Now, how did it turn out to be 1? Well, when they created the metric system, that was the plan. 1 cubic centimeter was going to weigh 1 gram. So density is 1 gram per 1 cubic centimeter. They intended it for the answer to be 1. Okay? So all of these things, are man's choice. Did God say, no, you guys picked the wrong units? No, that's not the way God works. God can change it to any unit you have. He knows it instantly, if you're using those units, what your answer is going to be. He knows infinitely all that kind of stuff. And it's totally okay. God didn't even in the Old Testament tell them what masses to use to weigh out things, like goods and products and stuff like that, He didn't care what they picked. The only rules he had, that he gave, is you have to just, when you're buying and selling, you have to just use the same ones all the time. Otherwise, you're cheating. You know, that's the only restrictions he had. I don't care what you have, what you use. And in fact, he forbid them from having more than one. It was a, you know, according to God's law, you couldn't have more than one standard. You only could have one. Doesn't mean everybody has to have the same standard. It's just that when we're buying and selling, if I was gonna buy something from you and then sell something back to you, whatever units I used, you had to use the same one at that time. But if you were buying and selling from somebody else, you can use whatever units you want. God didn't care. So there's nothing God-given about the units. Because it really doesn't matter what we pick, as long as we're consistent. It's sort of like when you play games. It doesn't matter what the rules of the game are, as long as everybody's playing by the same rules. I mean, certain rules make the game less fun, you know, but it doesn't matter as long as everybody, and the only time the arguments arise is when somebody either doesn't understand the rule or somebody's changing the rules, right? Now, notice that, so we have ice is slightly less dense than water. Lead has a density of 11 times as, in other words, if I had this much lead, you know, a cubic centimeter of lead, it would weigh 11 times as much as the same amount of water would. That's what that means. Or mercury is almost 14 times as heavy as the same amount of water. But there's a lot of things that are less dense. The only reason why water isn't exactly 1, you know, it's 0.998, that's really close to 1, is just because of when it was originally set up, they couldn't make it as precise as we can make it today. So it's close, it's really close to 1. Oh, I forgot to, density is a characteristic property of a substance. So that's one of the things, for instance, you know, if, you know, when they were looking for gold and stuff like that, some people would find what they thought was gold, but it actually was fool's gold. It's heavy too, but it's just not as heavy as gold. And so if you could figure out the density of each, you would realize which one's gold and which one's is fool's gold. Okay, so let's do a problem so that we can practice this idea. Let's say we have a sample of aluminum metal and it has a mass of 8.4 grams. So we put it on the scale, we got 8.4 grams. Its volume is 3.1 cubic centimeter. So what is its density? So here's a little reminder of what we did back in physical science. For those of you that were here, we always list what's given. So the first thing that was given is 8.4 grams. And that is a measure of what quantity? 8.4 grams is a measure of what quantity? I'm measuring what? The mass. And so I'm going to put an M down here for mass. Okay, so I'm solving the problem. I write down M equals 8.4. And then I have a volume. So they already tell you this is going to be a V. And it is 3.1 cubic centimeters. So I'm going to write that down like that. And they want us to calculate what? Density. What's the letter for density? We're going to use the letter D. Question mark. Okay? So write that down. So this, when it comes to showing you work, this is part of it. We only need one more thing to have shown all the work, and what would it be? Anybody remember? I need to have the equation, right? So what's the relationship between those that we had from a previous slide? Density is equal to mass divided by volume. Well, I should use a lowercase technically, but it doesn't really matter that much. Density divided by, density is mass divided by volume. One of the things that, do you remember we talked about the magic triangle when solving some of these that had 3 pieces in it. And the magic triangle, you just draw a triangle like this, divide it in half, and then divide the bottom in half. And what you do is you look at the side that has more than one letter, and you decide, well, one has to be over the other. Mass is over volume, so to make it be mass over volume, I'll have to put the mass on the top and the volume in one of these 2 places. And the density goes in this one. So if I want to find out what the density is, if I've been given mass and volume, I cover that one up. It's just mass divided by volume. But if they were asking for volume, it would be mass divided by density. Or if they want to know what is the mass, I'm going to take density times volume. So that's what the magic triangle is. It depends, if math isn't your strong point, magic triangles are your answer to that. So there's the list of the givens. Our unknown was density. Our solution is just 8.4 grams divided by 3.1 cubic centimeters. And then on my calculator, it's going to have more digits than that. Yes, Lennon?
Does that only work for the density formula?
The magic triangle can work for others as well. So when we come with other equations, I'll show you how to use the magic triangle for that. But it only really works for things that have 3 pieces. If they have more pieces, which sometimes we run into those, then it doesn't work real well. Okay, so on my calculator, if I take 8.4 divided by 3.1, I get 2.709677419. But that's way more digits than I could possibly ever get from that. So does anybody remember what the rules are for writing down what my answer is? How many significant digits should my answer have? Well, I look at my 2 numbers. 8.4 has how many significant digits? How many digits are there? 2, right? And 3.1 has 2. Well, the rule is that when I'm multiplying or dividing, my answer can't have any more significant digits than the number that had the least. Well, they both have 3.1, so we're just going to round it off to 2 significant digits. So instead of 2.709677419, I'm only going to take the first 2 digits, 2.7. Or if I had to round, I would round. So that's the reason why the answer is 2.7, not with more digits than that. So this year, we'll talk more about significant digits in here. We will keep track of that. If you have the right answer but just the wrong number of digits, then we write an SD next to it. And when you get to 4 SDs, if you remember from 2 years ago, then you take an extra point off. Usually most people don't lose any points. If you're taking care, you don't usually miss it that many times unless you're not paying attention to it at all. Okay, so what I was doing over here before, when I was converting a cubic meter into cubic centimeters, I was using a conversion factor. The conversion factor was that there are 100 centimeters in 1 meter. So conversion factors are always a ratio. Remember, it's always going to be like a fraction. One thing divided by another. And the thing on the top is equal to the thing on the bottom. So if the value of the top of a fraction is the same as the value at the bottom of the fraction, that fraction is always equal to what? If the value on the top of a fraction is the same as the value on the bottom of the fraction, that fraction is equal to 1. How many times can I multiply by 1 before I change the answer? Never, right? So I can do it as many times as I want. I can have as many conversion factors. I had 3 of them there to convert that. So because you're always multiplying by 1. I'm not changing the actual answer. I'm just changing it into a different unit. I'm just saying, how do you say the same thing with different units? So you're gonna take whatever quantity that was sought, like the example I had was cubic centimeters, and I take the quantity given, which was 1 cubic meter, and then I multiplied it by the conversion factor, however many times I had to multiply it by. So let's just take something we can do quickly in our head. They want to know how many quarters in $12. Okay, so how many quarters is what's sought? The quantity that's given is the $12, and what's my conversion factor between dollars and quarters? What's my conversion factor? How many quarters make $1? 4. So my conversion factor is like $1 over 4 quarters, or 4 quarters over $1, however you want to say that, because they mean the same thing. Okay? So the number of quarters equals $12 times my conversion factors, which is 4 quarters per dollar. Now, how do you know which way to write the conversion factor? I need to write it in such a way that I can cancel out the units I started with and end up with the units that my answer is supposed to be in. So like this case, I want it to be in quarters. So I have to put the dollars on the bottom over here, so they'll cancel out to get quarters. Okay, now you can make up other conversion factors as long as you know what relationships exist. Like I could change miles into feet if I just knew what the conversion factor was between feet and miles. 5,280 feet equals a mile. Or whatever the conversion factor is. So changing like meters into decimeters, I just need to know how many decimeters does it take to make a meter. That's my conversion factor. So when it comes to listing conversion factors, you can say it a lot of different ways, but when you actually use it, you just have to make sure that your units will cancel out with my conversion factor. So I can flip my conversion factor over if necessary to get the units to cancel out. So 1 meter is equal to 10 decimeters, but you notice the one in the middle is just another way of saying a decimeter is actually 1/10 of a meter, so 1/10 of a meter is the same thing as a decimeter. So I could use that as well. Or I can flip it over like the last one is. So when you are converting these, think about the prefixes like that's on that chart that's over there on the wall. If I'm going to a bigger unit, then my number has to get smaller, right? Because I'm using bigger units, I'll have a smaller number. If I'm going to smaller units, like it's what's below that brown line, I'd say, then my answer gets bigger. Because if I'm going to smaller units, then my answer has to be bigger to say it that way. Okay, so let's practice this. Express the mass of 5.712 grams in milligrams. Okay, so the answer sought is going to be in milligrams. The answer given is 5.712, and I need now a conversion factor. What's my conversion factor between grams and milligrams? Well, what does milli mean? Yeah, 1,000th of something, right? So 1 gram equals 0.001 grams. 1 milligram is equal to 0.001 grams. Or you could say it the other way, that 1,000 milligrams equals 1 gram. That would also be true. So there's my given, there's my conversion factor. 1 gram is 1,000 milligrams, but this conversion factor also works. That 1 milligram is equal to 0.001 grams. That's also true. So it does, there's not just always one conversion factor. There can be more than one. So those are the other things that you could have. Okay, we'll probably use that one, or we could use this one that I have right here as well. And so I write down what's given, my 5.712 grams over 1, and then I write my conversion factor in such a way that my grams will cancel out. I want my grams to cancel out, because I want my answer to be in milligrams. So I'm just going to take grams multiplied by 1,000. My answer is 5,712 milligrams. Now, here's one thing to talk about when it comes to writing your answer in significant digits. If all you're doing is using a conversion factor, the number of significant digits doesn't change because I'm actually just multiplying by 1, which is a whole number. Conversion factors do not change the number of significant digits. They still have to stay the same. So here would, like if I was changing grams into kilograms, then again, my grams has to be on the bottom, and kilo means 1,000, so 1 kilogram equals 1,000 grams. Or again, I could write that one as 1 gram is equal to 0.001 kilograms, okay? Which isn't just another way of saying the same thing. One of those maybe makes more sense to you, so use that one. So there's not just exactly one way to do it. There's a lot of these have more than one way of doing it. Okay, so that takes us to the end of this section. Our worksheet is on the printer, so we'll get it.